In this fourth lesson, I'm going to try and introduce you to another way of thinking about how these problems, how this phenomenology, how these discrepancies between what we see and what's out there physically can be explained. And this is an empirical explanation that depends on using our experience, not over just our lifetimes, but our experience with information translated from the world onto retinal images over evolutionary time as well as our lifetime to generate a method, a way, a strategy of getting around the inverse problem. So let me first of all remind you what the problem is. We talked about this before in some detail, but let me tell you again that the inverse problem refers to the fact that retinal stimuli, images on the retina, entail an entanglement of all of the information that comes from the real world. The illumination, the reflectance of surfaces, the transmittance are all entangled on what comes to the eye as a stimulus and falls on the retina. So we have no way of getting back logically from the stimulus to the contribution of the illuminant, the surfaces that we need to understand in terms of their properties, the transmittance of the atmosphere. All of these things are conflated in the retinal image and make it very hard for us to understand how it is that we're able to succeed in the world through the aegis of vision. And my point in this exercise is to try and explain how we can get around the inverse problem, and in the course of doing so, understand why it is that equiluminant patches look different from their physical reality in our perceptual domain of seeing light and dark. And the thing to keep in mind as I do this is that basically we have learned what the relationships are between the physical world and our internal world of perceived information as a means of solving this otherwise intractable problem of the conflation of information in any retinal stimuli, not just light and dark, but as we'll see in other modules, it applies to all of the qualities that we need to see to get along in the world. So let's consider what we need to do this. And the first thing that would be, I think, evident that we need is information about what our human experience has always been. What's been our experience with natural images? And you might think, well, okay, this is an unsolvable problem. How are we going to know what our human experience over millions of years of human evolution have been with natural images? And how can we use that experience to try and sort out the means by which we get around the inverse problem? Well, it's not as complicated as you might think, in the sense that the world hasn't changed very much over the 3 or 4 million years of human evolution. And we can, of course, get a large database of natural scenes by simply taking photographs like these 4 examples, but you can use thousands of examples and sample them millions and millions of times to understand what our human experience has always been. What have been the prevalences of images falling on the retina from the nature of the natural world. So one thing you have to be aware of right away is that it's no good to think of images in their entirety like these. This is, of course, what we are aware of seeing, but we're talking about learning from experience. And the fact is that for any image like this, any natural images like these 4 examples or any other, you're in effect only going to have seen that image once. Remember, there are millions of photoreceptors on each of our retinas, and we're only going to have had those photoreceptors activated in exactly the same way once in relation to retinal images like this. Why? It's simple. It's because the detail in the activation of millions of photoreceptors by a natural image doesn't happen many times. It happens only once effectively or conceivably a very few times. But to learn stuff, you need to see things many times, whether you're learning a language or whether you're learning to play a musical instrument or anything that you learn. You need to see and practice many, many times the characteristics that you're trying to embed in your memory stores. Again, memory, we're not talking about individual memory, we're talking about human species memory. So it's no good to use images and imagine that we are somehow learning from the image in its entirety. We're learning about lightness and darkness and its relationship to our perceptions in terms of little patches of light and dark. These are patches that are on the order of size of the receptive fields in the center of vision, in the primary visual cortex. Remember, we talked about those. Those are fractions of a degree, or maybe a degree or two. When you take a small piece of images like that and sample them many millions of times, of course you can get a pretty good idea of what the relationships have been over the millennia of evolutionary time, what the relationships have been between luminance relationships in the real world and little patches of the real world that we see time and time again, and how those might be related, could be related to our experience based on that empirical evidence. So what we're going to do is to try and explain this phenomenon, this simplest of all the luminance discrepancies that we talked about, in terms of experience derived from natural images, and we're going to talk about the experience in terms of sampling natural images with little patches like this many, many millions of times and extracting the gist of our human experience from that evidence.